We'll learn about the vector equation of plane. Vector equation of plane. Now you have a plane like this. The plane is passing through the points, 3 points A, B and C. Then the vector equation of this plane is given by R is equal to 1 minus S minus T into A plus SB plus TC. This is the equation where S and T are scalars. They are real numbers. So the vector equation of a plane passing through 3 points is this. 1 minus R is equal to, that R is very important. If you don't write that R, you will not be given mark. So R is equal to 1 minus S minus T into A plus SB plus TC. Now next is the plane is passing through only 2 points, A and B, and it is parallel to some vector C, only one vector. So the plane is passing through 2 points and parallel to the vector C. In that case, the equation is R is equal to 1 minus S into A plus SB plus TC. Now the third one is the plane is passing through only 1 point. You are given only 1 point and you are given 2 vectors. The plane is parallel to these 3 vectors B and C. So this is the vector C. So 1 point and parallel to 2 vectors. So vector equation of the plane passing through 1 point and parallel to 2 vectors is R is equal to A plus SB plus TC, where S and T are real numbers. Now you can easily remember like this. In all the 3 equations you have SB plus TC, SB plus TC. Here A, B, C are all points. All the 3 are points and you have 1 minus S minus T. Here only B, A and B are points. So you have 1 minus S into A plus SB plus T. Here only A is a point, B and C are vectors. So this is the equation. Understand the difference and by heart the equation. Okay. Now we have 2 theorems and then proof is not necessary. Just learn the theorems. 3 points A, B, C are collinear. 3 points lie on a straight line or they may be parallel. If and only if there exist scalars xyz not all 0 such that xa plus yb plus zc is equal to 0 and x plus y plus z is equal to 0. So you can, if the 3 points are collinear, then you have this condition xa plus yb plus zc. And in fact, we were using the same thing in problems, but there we were writing, we were converting ab is equal to some lambda times ac, or if you can write one vector or A is equal to some TB, then we say that A and B are collinear. So A is AB vector, B is AC vector, like that. So this is the actual theorem. Next 4 points A, B, C, D are coplanar. Coplanar if you have this condition. This is the condition. This only actually we were using in the earlier problems. XA, we were converting them to 3 vectors. AB, AC, AD, and then we were writing AB as X times AC, Y times B, AD like that, and we were solving. In fact, there we were using this theorem. So just these are the statements. These are the statements. You can just learn. So the first problem is to find the vector equation of the line passing through the point and parallel to the vector. So you are given the point. The point A is 2i plus 3j plus k and parallel to the vector B and parallel to the vector B. What is B? 4i minus 2j plus 3k. So now therefore, what is the equation? The vector equation of the vector equation of the line passing through the point A, passing through the point A and parallel to the vector and parallel to the vector B and parallel to the vector B is, first write the formula, is R is equal to A plus TB. So that means R is equal to A, substitute A point, 2i plus 3j plus k passing through the point A and parallel to the vector B. So T into B, B is 4i minus 2j plus 3k. So this is your answer. r is equal to, where t is a real number. T is a real number. That's all. Now next is OABC is a parallelogram. So you are given a parallelogram OABC. OA is A and OC is C. So that means you must find the equation of the side BC. Equation of this side you have to find out. So what you do here, BC is passing through the point C and it is parallel to the vector A. So it is similar to this. So the side BC or the line BC is passing through the point C and parallel to the vector A. OA, parallel to the vector OA, that is A. So parallel to the vector A and passing through the point C. Point is C and vector is A. So therefore the equation of the side BC, vector equation of the side BC, the vector equation of the side BC is r is equal to, is passing through the point C and parallel to the vector A. So A, r is equal to, so therefore the answer is r is equal to C plus T into A, where T is a real number. Okay. Now next problem. Now the next problem is ABC are the position vectors of the points ABC of triangle ABC. Find the vector equation of the median through the vertex A. So through the vertex A, median means it should pass through the midpoint of the opposite side BC. So D is the midpoint. So what is the mid? A is equal to, you are given A is equal to OA is equal to A, and then B is equal to OB is equal to B, and then C is equal to OC is equal to C. Now D means OD. What is the midpoint formula? D is the midpoint of, it is the midpoint of BC. So what is its position vector? B plus C by 2. Now the median AD is passing through 2 points A and D. The median AD passes through the points A and D. So what is the vector equation of the line passing through 2 points? So the vector equation of AD is median AD. Vector equation of median AD is r is equal to 1 minus T into A plus TB. Vector equation of the line passing through 2 points A and B is this. So that means here it is r is equal to 1 minus T into, so this is the formula. So your answer is this, r is equal to 1 minus T into A plus T into B. Another point here is B point. What is B point? B plus C by 2. B plus C by 2, where T belongs to R. So this is your answer. So we are using this formula, vector equation of the line passing through 2 points A and B is this. But our points here are A and B plus C by 2. So this is just a formula. This is formula and you are applying this problem. So is this implies. So this is your answer. Next is vector equation of the line passing through 2 points. So it is direct problem, that problem only. So suppose that the points, let A is equal to 2I plus J plus 3K, and then B is equal to minus 4I plus 3J minus K. So therefore the vector equation of the line passing or joining anything, joining the points A and B is r is equal to 1 minus T into A plus TB. Or you can also use the formula R is equal to A plus T into B minus A. Any formula you can use. So that means R is equal to 1 minus T into A. Or else I'll use this formula. Any one you can use. 1 minus T into A. What is A? 2I plus J plus 3K. A plus TB. T into what is B? This. Minus 4I plus 3J minus K. You can leave your answer like this, or you can further simplify and write as R is equal to what is I coefficient, like this you can simplify, or else leave it like this. It is enough. So this is your answer. Yes. Now the next problem is find the vector equation of the plane passing through 3 points. These are the 3 points. So we know the formula, the vector equation. The vector equation of the plane. The vector equation of the plane passing through 3 points. Passing through 3 points. We will take the points as first one as I minus 2j plus 5k, 3 points A, and then B is equal to minus 5j minus k, and C is equal to minus 3I plus 5j. Is we have the formula R is equal to 1 minus S minus T into A plus SB plus TC, where S and T are real numbers. This is the formula. SB plus TC. Okay. Now we'll substitute. So the answer is R is equal to 1 minus S minus T into A point you must substitute. I minus 2J plus 5K plus S into B point. What is B point? Minus 5J minus K. Minus K. And then T into C point. C point is minus 3I plus 5J. That's all, where S and T are real numbers. This is your answer. So just to substitute. Now in the same way you can try the second problem. So instead of A you will write a 0. So that means when this is 0 you won't be having that term. So for the second problem the answer is R is equal to SB 0. This is 0. So it will be S into, it is just a 5J. 050 means 0I plus 5J plus 0K. So it is just 5J. And then plus T into 2I plus K, where K, S and T are real numbers. This is your answer. Yes. Next problem. Using the vector equation of straight line passing through 2 points. Here he has given 3 points. You must show that they are collinear. So what we do is we'll write the equation, the vector equation of the line. The vector equation of the line passing through 2 points. The vector equation of the line passing through 2 points A and B is what? A and B is R is equal to 1 minus T into A plus TB. This is the equation. We know this formula. Now we'll substitute. How to substitute a point in the equation, in the vector equation? So substituting, you must substitute for R here. Substituting 3A minus 2B, because R is the variable vector. 3A minus 2B in equation 1. In first equation, we get, in 1 we get, so you must, when you are substituting any point in an equation, it should be for R. So 3A minus 2B is equal to 1 minus T into A plus TB. Now equating the coefficients of like vectors. So you'll get 3 is equal to 1 minus T, and then minus 2 is equal to T. So T is equal to minus 2, no? Substitute in this. T is equal to minus 2. When you substitute in the first equation, you are getting 3 is equal to 1 minus of minus 2. It is satisfied. So that means both the equations have the same T value. That means This point implies that the point 3a minus 2b, the point 3a minus 2b, the point 3a minus 2b satisfies equation 1. Equation 1. So that means the point 3a minus 2b, the point 3a minus 2b lies on line 1, lies on the line 1. So that means they are all in the same straight line. Therefore, the points are collinear. Therefore, the points A, B, and then 3A minus 2B are collinear. Next problem. The next problem is show that the line joining the pair of points and the line joining the pair of points intersect at the point. So you have the points like this, A, B are on one straight line, and then C, D are on one straight line. C is the point and D is the point. You must find this point of intersection. Like how you do in 2 dimensions, same procedure. So you take the first point as A, you'll take them as L bar and then B as M bar. Then the vector equation of the line AB is R is equal to 1 minus T into A plus TB. So T into M, second vector B. So that means R is equal to, the equation is R is equal to 1 minus T into, R will write the equation in this form. R is equal to L plus M T into B minus A. L plus T into M minus N. M minus L. Like this will write. So it implies R is equal to L. What is L? L is 6A minus 4B plus 4C plus T into M minus L. M minus L. This minus this. So it is minus 6A plus 4B minus 8C. Minus 8C. So this is equation 1. Now in the same way, take this point C and D like this, P and Q. The vector equation of the line CD is R is equal to 1 minus, you take different letter. Instead of S, T you take S. S into P, or else we'll take this equation. R is equal to P plus S into Q minus T. So that means R is equal to P. What is P? Minus A minus 2B minus 3C plus S into Q minus 3. This minus this is 2A and then plus 4B minus 2C. This is second equation. Now to solve these two equations, you will equate R values. This R value is equal to this R value. So solving 1 and 2, we get R value. We were solving the equations. We were solving the equations 1 and 2. So to solve the equations 1 and 2, we'll equate the R coefficient, R values. R is this. This is equal to this R value. We equate it. So we'll simplify. A coefficient will simplify, B coefficient, C coefficient. In the same way here also A coefficients minus 1 plus 2s and then B coefficient minus 2 plus 4s, like that will simplify. Now since they are coplanar, A, B, C are non-coplanar, you can equate the coefficients of like vectors. A coefficient this side is equal to A coefficient this side. So you can just try, you can do the calculation, simplifications on your own. So you'll get 3 equations like this. Again, when you take all the terms this side, you will get the equations like this. Now number them as 3, 4 and 5. Solve only 2 equations. So when you solve 3 and 4, solving 3 and 4 here, you are solving 3 and 4. You will get T as 1 and S as half. Now substitute them in the fifth equation. It is satisfied. So substituting in 5, it is satisfied. So when the third equation is satisfied, then the lines intersect. If the third equation is not satisfied, then they do not intersect. So the point of intersection is obtained by substituting t is equal to 1. You got t as 1. So substitute t is equal to 1 in 1 or s is equal to half in this. Any one is enough to find the point of intersection. So when you substitute t as 1 here, what happens? You will get only minus 4c. 6a, 6a will get cancelled. 4b also gets cancelled. So you will get minus 4c. So minus 4c is the point of intersection. Hence it is proved. Now we'll continue with the next problem. It's very important and it is a very lengthy problem. So I just solved. Now I'll explain. You first understand, you can try this problem. These calculations you can do on your own. You need not look into the simplifications what I did here. So you must find the vector equation of the plane passing through 3 points. And you must show that the fourth point lies in this plane. So that means it is almost like the 4 points are coplanar. So what you do is first write the equation of the plane passing through the points A, B and C. Take them as A, B and C and we have the formula R is equal to 1 minus S into T, 1 minus S minus T into A plus SB plus TC. So substitute, you'll get the equation. Then just multiply, collect the coefficients of I, J. Here I coefficient 4 minus 4S minus 4T and then 3S and then 2T. So like that you simplify and then you substitute the point, the fourth point that is given in the place of R. So when you substitute, because they are non-coplanar, equate the coefficients of I and then J and then K. You will get the equations like this. So simplify constants, taking simplify and then you have the 3 equations. Now solve any 2 equations. So first 2 I solved and I got the values of S and T like this. When you substitute in the third equation, it is satisfied. It is satisfied. So since the equation 3 is satisfied, the point lies in the plane passing through the points A, B, C. So the points, all the 4 points are coplanar. He didn't ask here to prove that they are coplanar. You are asked to just show that the point lies in the plane. So this is the procedure to show that any point lies in the plane. Now we have one more problem left. After that, we will write 2 homework problems. With that, we'll complete this chapter. Now the next problem is, in the 2-dimensional plane, prove by using vector methods that the equation of the line whose intercepts on the axis are A and B is x by A plus y by B is equal to 1. You know this equation. It is the intercept form of the straight line. So the intercepts of the line are A and B is given. So A is A0 and 0B. These are the 2 points in the 2-dimensional plane. So you will not have Z axis. Third coordinate won't be there. So these are the points on the coordinate axis. So that means you can write a point, that is OA vector. In terms of vectors, it is just AI 0J. That is not there, no. So A is equal to AI. Similarly, B is equal to OB vector, that is BJ. Now the vector equation of the line. The vector equation of the line passing through 2 points. Of the line passing through 2 points. What are the 2 points OA and OB? 2 points OA and OB is, according to the formula we have as R is equal to 1 minus T into A. A means OA and plus TB. 1 minus T into A plus TB. B means OB. So that means it is R is equal to 1 minus T into AI plus T into BJ. Now we'll take R is equal to Xi plus Yj. It is a variable vector. So variable vector R is Actually xi plus yj, xyz point like. So it is xi plus yj plus zk. Here k is not there because it is two dimensional. So write r as xi plus yj. So r is equal to xi plus yj is equal to 1 minus t into ai plus tb into j cap. Now I, j are non-coplanar. So you equate the coefficients of I and j. So I and j are non-coplanar. I, j are non-coplanar. So it implies equating the coefficients, you get x is equal to 1 minus t and then y is equal to tb. So that means x is equal to 1 minus t into a. 1 minus t into a. So from this you will get y by b. Y by b is equal to y by b is equal to t. Now substitute this y by b in this. So x by a is equal to 1 minus t. So that means x by a is equal to 1 minus y by b. So x by a, substitute y by b, t value in this. X by a plus y by b is equal to 1 is the required equation. This is the required equation. So that is how we solve the problem. So we'll take the points in two dimensions like this, ai and then bj, because it is on x-axis and y-axis. Now write the vector equation of the line passing through 2 points as r is equal to 1 minus t into a. A point is this, OA. So I am writing OA and t into b. B point is OB. So I am substituting, and then always we take the variable vector as xi plus yj plus zk. So we'll write is k is not there here because it is two dimensions. So equate and then eliminate this t. T is a real number, no? So eliminate t. T is real number. So by eliminating t, you will get the equation in terms of the coordinates x and y. Now take down the homework, two problems. With that, we'll complete the chapter. Pause. Problems. I'll explain how to do the problems. A, B, C are non-coplanar. Find the point of intersection of the line joining these 2 points with the line joining these 2 points. This type of problem we already solved. So write the equation of the line passing through these 2 points as r is equal to 1 minus s into a. This is your a plus 1 minus s into a plus sb. This is your b. That is one equation. Another equation is r is equal to 1 minus t into a plus tb, like this. Then equate the coefficients, equate r values, and then you'll get 3 equations, solve them. And then after getting s and t values, substitute in any one of the equations, you'll get that point. We solve similar problem. You can try it as lengthy problem. These two are lengthy problems, 7-mark type questions, but you can expect them for 4 marks also. So find the point of intersection of the line and the plane. Procedure is same. Equate r values, find out, equate the coefficient. This is very simple. You will get it very easily. Substitute the values, equate the coefficients of like vectors, find out find out t, x and y. Instead of s t here you have x, y, t. So find out any one value, and then all the 3 equations should satisfy these values. Then after finding t, you substitute in this, you'll get the answer like this. You can try. With this, we completed this chapter. You just try these problems and then try all the problems which are solved in the class. Please try all the problems which are solved in all these 7 periods. We covered almost each and every problem which you get in the exam. So if you just try these problems that I solved in the class, that is enough. The 7 periods problems are enough for you to solve any problem in the exam. Okay, learn all the formulae and then try this problem. Practice this problem. Now, next period we'll do product of vectors.